Good morning, Year 11s. We are going to have a quick look at linear inequalities, number lines and set notations. Okay, so inequalities you solve by the exact same means as you would an equation, but I want you just to look, there are no equal signs in any of this. You need to shake off the equal sign as you're doing the working. Okay, so the first one was subtracting 7 dividing by 4. There's no reason to change the direction of our inequality sign, so we don't. In the second equation, you can, if you swap the sides, 2x and 6, you have to keep the inequality pointing at the same thing, in this case 6. So it changes direction if we swap sides. Also, if I don't do that, you can see the other method down the right-hand side. At some point, I'm going to need to divide by a negative. -2 in this case. And if that happens, that's the other time when we multiply or divide by a negative that we need to swap the direction of our inequality. And you see it happening right there. Okay, so this is from GCSE and it's not especially really high order GCSE. So we can just plot our two inequality solutions onto the number line. And once that is done, we can see values where both are true. So when x is greater than -1 and x is greater than 3, well, the only numbers that do both of those things are the numbers that are greater than 3. And so that's why you see that as the final solution to this problem. I'd like to look at a few cases when you solve your inequalities, the different things you might get on the number line. So you might get something like this, where x is less than or equal to 3, or x is greater than 7. Of course, no numbers are both of those things, so we're forced into this or situation. Or you may get asked to write this in set notation, and what that means is a curly bracket followed by x. So these are the x values, and that colon translates directly in maths to such that. So we're after the x's such that x is less than 3 or x is greater than 7. And that's a direct translation of what set notation is saying. It means exactly the same thing, but you do need to use a union sign, you do need to use a colon, and you do need to use x at the beginning. Okay, so what about if we get something that's connected like this? Now, you often see three-part inequalities, and that's still going to be okay. But there is another way, and I want you to see it. Now, in this case, we need to have both x is greater than -3 and x is less than or equal to 5. If we had or there, any value of x could be one of those. So any value of x would satisfy one or other. So we don't use or, we have to really use and for this to make sense. So we could say x such that x is greater than -3 and x is less than or equal to 5. So that symbol, the intersection symbol, means and. We can write it as a three-part inequality, and that's perfectly okay. I just want to expose you to this particular symbol and how to use it inside set notation. Right, time for you to crack on with some of the highlighted questions.